Assalamualaikum and hi everyone. Today we are going to learn about chapter 8 random variables. In this chapter there are 3 subtopics. 8.1 Introduction to random variables, 8.2 Discrete random variables and 8.3 Continuous random variables. At the end of lesson, students should be able to first understand the concept of discrete and continuous random variables. Second, construct probability distribution table and probability distribution function. Third, solve problems related to probability distribution function. What is a random variable? A random variable is a variable whose value depends on the outcome of a random experiment. We usually denote random variables by capital letters such as X or Y. There are two types of random variables: discrete random variables and continuous random variables. A discrete random variable is a random variable that assumes countable values. Example, the number of children in a family can be either 0, 1, 2, 3 or any possible natural numbers. It is not logical to have 2.5 number of children per family. It means the number of children in a family is countable. Therefore, the number of children in a family is a discrete random variable. Another example for discrete random variable are the number of new accounts opened at a bank during a certain month. Next, the number of vehicles owned by families, or the number of students who drive to college each day. What is continuous random variable? Continuous random variables cannot have exact values, but they can have any values within an interval. Example, the time taken to use the auto teller machine from one user to another. We can assume the time taken between 3 minutes to 8 minutes. It means the time taken can take any value within the interval. Example, 3.5 minutes or 3.8 minutes. Therefore, the time taken to use the auto teller machine is a continuous random variable. Another example for continuous random variable are the wage of newborn babies in a country, or the time students spend doing homework, or the price of concert ticket. Discrete random variable. The function that is used to define a discrete random variable is known as probability distribution function, or PDF. The probability distribution is usually denoted by Px equal x and read as the probability when a random variable x is x. The capital X is the random variable. Example, let x be the sum of the score on the two dice. Small x is a value that x can take. Then, x can take the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. To make you understand better, look at this example. Next, consider the experiment where two coins are tossed simultaneously. Let x be a discrete random variable, that is, the number of heads obtained when the two coins are tossed. Let h is denoted for head and T is denoted for tail. When we toss two coins simultaneously, then the possible outcomes are 2 head, 1 head, and 2 tails. Therefore, total number of outcomes are 4. So, when two coins are tossed, the number of heads obtained is 0, 1, and 2. Therefore, X can take the values 0, 1, and 2 only. Therefore, the probability of getting no head is PTT equal 1 over 4. The probability of getting one head is PHT plus PTH equal 1 over 2. And probability of getting two head is PHH equal 1 over 4. The sum of all the probability is equal 1. The probability distribution of this discrete random variable X can be represented by the table. From this table, Px equal 0 is 1 over 4, Px equal 1 is 1 over 2, Px equal 2 is 1 over 4. The above relationship can also be written as a function. Fx equal 1 over 4 for x equal 0 and 2. Fx equal 1 over 2 for x equal 1 and 0 otherwise. Fx is called the probability distribution function. The probability distribution function can also be represented by a graph. Okay, from graph, F0 equal 1 over 4, F1 equal 1 over 2, F2 equal 1 over 4. Two characteristics of a discrete random variable are the probability of each value of a discrete random variable is between 0 and 1, and the sum of all the possible probability is 1. Example 1, show that Fx equal x squared over 55 for x equal 1, 2, 3, 4, 5 is probability distribution function of a discrete random variable x. Hence, find A. Probability of x equal 3, B. Probability of x more than 3, C. Probability of x less than equal 3, D. Probability of x more than 2 less than equal 5, E. Probability of x more than equal to less than equal 4. So, to show this is probability distribution function, we need to show that the sum of all the probability is 1. The function given is x squared over 55 for x equal 1, 2, 3, 4, and 5. To find the sum of all the probability, we substitute x equal 1, 2, 3, 4, and 5 in this function. So, we get 1 squared over 55 plus 2 squared over 55 plus 3 squared over 55 plus 4 squared over 55 plus 5 squared over 55, and we get 1. Therefore, Fx is a probability distribution function of a discrete random variable x. How to evaluate Px equal 3? Okay, Px equal 3 is F3. To find F3, we just substitute x equal 3 into given function. So, we get 3 squared over 55, and the answer is 9 over 55. How to find px more than 3? Okay, the value of x is 1, 2, 3, 4, and 5 only. So, px more than 3 is px equal 4 plus px equal 5 only. So, we substitute x equal 4 and x equal 5 into given function, and we get the answer is 41 over 55. C, p at less than equal 3. Okay, the given function is fx equal x squared over 55 for x equal 1, 2, 3, 4, and 5. So, p at less than equal 3 equal px equal 1 plus px equal 2 plus px equal 3 only. So, px equal 1 is f1, px equal 2 is f2, px equal 3 is f3. We just substitute x equal 1, x equal 2, x equal 3 into given function. So, the answer is 14 over 55. D, probability x more than 2 less than equal 5 is probability x more than equal 3 less than equal 5. Means, we have to find the sum of probability x equal 3, x equal 4, and probability x equal 5. So, we just substitute x equal 3, x equal 4, and x equal 5 into a given formula. So, we get 3 squared over 55 plus 4 squared over 55 plus 5 squared over 55, and the answer is 10 over 11. E, the probability of x more than equal to less than equal 4 is px equal 2 plus px equal 3 plus px equal 4 is f2 plus f3 plus s4. We just substitute x equal 2, x equal 3, x equal 4 into formula given. So, we get the answer is 29 over 55. Example 2. The probability distribution for the random variable x is shown in the following table. A. Determine the value of k. B. Find the probabilities. B1 exactly 2. B2 more than 2. B3 at least 2. B4 at most 3. B5 1 to 3. B6 between 1 and 4. C. Sketch the graph fx. Okay, we know that the sum of all the probability is equal 1. So, from the table given, we get probability x equal 0 is k, probability x equal 1 is 2k, probability x equal 2 is 2k, probability x equal 3 is 3k, probability x equal 4 is k, and last, probability x equal 5 is k. Okay, next, we try to find the sum of all possible probability px equal 0 plus px equal 1 plus px equal 2 plus px equal 3 plus px equal 4 and plus px equal 5, and all must be equal to 1. Then we have k plus 2k plus 2k plus 3k plus k plus k equal 1, and we get 10k equal 1, and we simplify, we get the value of k is 1 over 10. B1 exactly 2 means we need to find the probability of x equal 2. From the table given, we know that probability of x equal 2 is 2k. Then we sub k equal 1 over 10. Hence, the probability of getting exactly 2 is 1 over 5. B2 more than 2. How do you write more than 2? Okay, this is the sign more than. More than 2 means 2 is not included. So, probability x more than 2 is the sum of probability x equal 3 and probability x equal 4 and probability x equal 5. So, from the table, we have 3k plus k plus k, and we get 5k. We substitute k equal 1 over 10, hence the probability of x more than 2 is 1 over 2. B3 at least 2. What is the sign for at least? Okay, this is a sign for at least, that is more than or equal. So, x more than or equal to means 2 is included. So, we start from x equal to. And probability x more than or equal to is probability x equal 2 plus probability x equal 3 plus probability x equal 4 plus probability x equal 5. Okay, from the table given, we have 2k plus 3k plus k plus k. And then we get 7k. We substitute k equal 1 over 10. And the answer is 7 over 10. 4 at most 3. Okay, this is the sign for at most. The sign is less than or equal. So, x less than or equal 3 means the value of x can be 3 or less than but cannot be more than 3. Okay, from this table, we know that probability at less than equal 3 is probability x equal 0 plus probability x equal 1 plus probability x equal 2 and plus probability x equal 3. So we have k plus 2k plus 2k plus 3k, and we get 8k. We substitute k equal 1 over 10 and we simplify. We have the answer 4 over 5. B5 1, 2, 3 means 1 and 3 are included. So we have x equal 1, x equal 2 and x equal 3. The possible sign is x more than or equal 1 and less than or equal 3. So the probability x more than equal 1 less than or equal 3 is, we find the sum px equal 1 px equal 2 and px equal 3. And then we sub the value of px equal 1, px equal 2, and px equal 3, and we get 7k. So we substitute k equal 1 over 10 and we get the answer 7 over 10. Since between 1 and 4, between means 1 and 4 are not included. So we can write it x more than 1 less than 4. So we have only x equal 2 and x equal 3. Okay, to find probability x more than 1 and less than 4, we add probability x equal 2 and probability x equal 3. Okay, and we get 5k. We simplify, hence the probability of x between 1 and 4 is 1 over 2. How to sketch the graph of probability distribution function? Based on the given table, we can plot the graph. X-axis denote the values that the random variable can take. That is 0, 1, 2, 3, 4, and 5. Y-axis denote the probability value. That is 1 over 10, 2 over 10, and 3 over 10. When x equals 0, px equals 0 is 1 over 10. We can draw a straight line parallel to the y-axis. Do the same thing for x equals 1, x equals 2, x equals 3, x equals 4, and x equals 5. Finish. This is a graph of probability distribution function.